So you think you know pipes, do you? It's just, well, pipes. You turn a knob, water flows, and that's it. But my dear friends, there's a lot more to it than meets the eye. There's an entire world beneath the surface, a world of valves, taps, and mechanical marvels that stop the flow, start the flow, and sometimes even prevent the entire world from flooding. This is the world of pipeline fittings, and let me tell you, it's far more exciting than you think. Now, let's talk about the ancient Roman water system. The Romans didn't have taps in every home. Instead, they used flowing water from aqueducts, and plug valves were primarily used to direct water to public baths, fountains, and other community buildings. If a wealthy villa owner wanted to connect directly to the city supply, they needed government approval and a hefty budget. Of course, bribery and illegal taps weren't uncommon. Human nature hasn't changed much in 2,000 years. And what's it called? A plug valve. Yes, the same basic design that kept water flowing back then is still in use today. Refined, modernized, but fundamentally unchanged. Classic engineering at its finest, proving that sometimes the simplest solutions are the most enduring. Fast forward to the 18th century, and pipes are getting more complex. Steam engines are driving factories, and without proper valves, those factories would, well, burn down. And that's when modern valve technology truly started to take shape. A simple water valve became more complex and durable, and that's the beginning of the advanced stuff we use today. Let's start with the king of all valves, the ball valve. It's simple, it's effective, and it does its job without fuss. You just turn the handle and boom, the water stops, or starts. It's that easy, even your grandmother could do it. Or in some cases, your hamster. Not that he'd need to turn off a pipe, but you get the point. The ball valve has been around for a while, and it really does its one job very well, stopping or starting the flow. It's like a reliable family sedan. It doesn't do anything flashy, but it will never let you down. But wait, there's more. The globe valve, this is the fancy cousin of the ball valve. It's used when you need to regulate the flow, not just stop it. These valves are often found in water treatment plants, chemical factories, and sometimes places where people think they're important enough to use a globe valve instead of a regular ball valve. However, if you decide to use a standard ball valve for regulating flow, let me stop you right there. Bad idea. Over time, its sealing mechanism will wear out, leaving it utterly useless. And then, everything you were so determined to keep contained will gush out like a plumbing apocalypse of catastrophic proportions. And surely you don't want that, do you? Now, let's get back to ball valves and give them the praise they deserve. These mechanical marvels are perfect for water and gas applications. They come in all shapes and sizes, made from various materials, mostly steel, though you'll find some made of plastic too. And their connection methods, oh, the variety is staggering. Welding, flanges, threads, you name it. They even come in the most peculiar designs. Just look at this angled valve, or this one with 3 ports. Honestly, the creativity in ball valve design never ceases to amaze me. And then there's PN, the pressure nominal rating. It's not just a random number stamped on the side of a valve. PN tells you how much pressure the valve can handle without exploding in your face. It ranges from low-pressure sips, like 10 bar, to pressure so intense it could probably launch a satellite, up to 1,000 bar. For context, a small stream of water from a high-pressure pipeline can slice through steel. Yes, steel. Now imagine standing too close. Lose a finger? Probably. Lose your mind? Definitely. Here's a little extra. Ball valves can have full bore or reduced bore. Full bore? That's when the opening matches the size of the pipe. Reduced bore? Well, let's just say it's smaller and cheaper. But we won't dwell too much on that because honestly, who needs that level of detail? Now for the engineering nerds among us, here's a fun fact. There are floating ball valves, clever little things that seal tightly against the seat due to pipe pressure. But when you scale up to those giant diameters, this trick doesn't quite work. Enter the trunnion-mounted ball valve, where the ball is securely fixed and the seats are spring-loaded to press tightly against it. Genius, right? Let's talk about the safety valve, that unsung hero of modern engineering. Found everywhere from your kitchen appliances and heating systems to massive industrial machinery like steam turbines or high-pressure pipelines, this humble device keeps chaos at bay. Here's how it works, in terms even your cat could understand. Pressure builds up in a system, and when it gets too high, the safety valve springs into action. Literally, a cleverly designed spring mechanism lifts the seal, allowing the excess pressure to escape and restoring balance. Without these valves, our systems would be ticking time bombs, waiting to unleash catastrophic energy. But thanks to their simple yet brilliant design, they keep the pressure where it belongs, in check. A true savior, and yet, just like all great heroes, they rarely get the credit they deserve. But let's not stop there. Now don't even get me started on check valves. They do exactly what it says on the tin, making sure nothing flows backwards. It's like the bouncer at your pipeline nightclub. Without it, chaos would reign. Trust me, you don't want to know what happens when water starts flowing in reverse. Now, talking about sizes and specs, valves can range from tiny DN10, around 0.4 inches, to enormous DN2000, over 6 feet. For pressure, they can handle anything from PN6, low pressure, to PN250, super high pressure, and beyond. These things are made of everything from basic cast iron to stainless steel, brass, and exotic alloys for the real heavy-duty jobs. Depending on the materials and size, prices can range from as little as $10 for small, low-pressure valves to well over $100,000 for massive high-pressure models. Valves are used everywhere, from oil rigs to your own kitchen sink. They're the unsung heroes, keeping everything flowing smoothly, often without you even knowing. Next up, the mighty gate valve. This is the one you call when you need to shut the pipe down completely. Think of it as the master of control. It's not quick, it's not flashy, but when it does its job, it does it with authority. It's like the bouncer at an exclusive club. No one gets in and no one gets out. Now, gate valves come in all shapes and sizes, with different gate designs like wedge and slide gates. Depending on your needs, you can find them in a variety of diameter and pressure ratings. For example, you could get a gate valve with a DN of 50 to 2000 and a PN rating from 10 to 100. They're made from materials like cast iron, stainless steel, or even brass, each suited for different types of work. And when it comes to price, you'll be looking at anywhere from $50 for the basic models, all the way up to $30,000 or more for heavy-duty, high-pressure versions. They may not be quick or flashy, but when it comes to doing the job right, they're the ones you want on your side. Now let's take a look at the butterfly valve. Sounds exotic, doesn't it? Well, it's really just a valve with a rotating disc. And when that disc closes, the flow is blocked. Quick and efficient, the butterfly valve is like a ninja. Silent, fast, and deadly precise in its work. It's perfect for situations where you need to adjust the flow quickly. Don't let the name fool you. This valve has nothing to do with insects. It's all about performance. As for the specs, butterfly valves come in a range of sizes, from tiny DN25, that's around 1 inch, to massive DN2000, over 6 feet. They can handle pressures from low PN6 all the way up to PN40, so there's something for every need. When it comes to materials, they're usually made from cast iron, stainless steel, or even exotic alloys for the most demanding jobs. For high-performance sealing, you'll find 2-way or 3-way eccentric disc designs that ensure perfect shutoff, even under extreme conditions. Prices? Well, for a basic DN100 butterfly valve, you're looking at about $100 to $300. But if you're in the market for a heavy-duty DN2000 valve made from stainless steel, prices can easily soar to over $20,000, depending on the complexity and specifications. Now, there are other types of valves out there, each with its own quirky way of doing things. Take the diaphragm valve, for instance. It's like a rubber glove that presses down on the flow, stopping it dead in its tracks, just like when you stop the flow of air from a balloon by pinching the end. Then there's the reducing valve. It's like the valve's way of saying, hey, let's calm things down a bit. It takes the pressure, turns it down, and keeps everything in a comfortable range. Simple, but effective. Finally, we have the pinch valve. It's as straightforward as it sounds. It literally pinches a flexible tube, shutting off the flow with a squeeze. It's a bit basic, but you can't argue with results. Each of these valves has a strange but effective way of managing the flow, proving that when it comes to keeping things contained, the engineering world is full of inventive ideas. If we're to keep it simple, all these types of shut-off or regulating valves have one thing in common. They all handle the flow direction differently. The valve's shut-off mechanism moves along the flow direction, while the gate valve takes a more sideways approach, blocking the flow perpendicular to the pipe. Then there's the ball valve. It rotates around its axis like a spin move in basketball, allowing or blocking flow depending on its position. And let's not forget the plug valve, which does something similar. It's all about how they move to control the flow, but in the end, they all get the job done. Each has its own way of blocking the flow, but the result is always the same. Things stay sealed, and the flow stays under control. But how do you make these valves move? That's where things get even more interesting. For small diameters, it's a matter of grabbing the handle, which comes in all shapes and sizes, and giving it a turn. Simple and effective. For the bigger beasts, though, you'll need a gearbox to assist with all that torque. And if that's still too much work, why not go high-tech? Remote operation using an electric actuator or a pneumatic drive lets you control the flow from a safe distance. Whether it's a twist of the wrist or the press of a button, there's a way to handle every valve, no matter its size. So, what have we learned? That valves are the unsung heroes of our piping systems. Whether it's turning off the water in your house or controlling the flow of chemicals in a factory, these little devices make the impossible possible. From the humble ball valve to the mighty gate valve and the swift butterfly valve, each one has its place in the world of pipes. And without them, well, we'd all be, as they say, up the creek without a paddle. Or more likely, drowning in it. So next time you turn on the tap, just remember, behind the scenes, there's a whole world of valves keeping everything flowing smoothly. And no, it's not as exciting as a car chase or a rocket launch, but it's definitely far more important. Thanks for watching. I hope you enjoyed it. Like, comment, and subscribe. And a big thanks to my wife Daria for her help.